I understand.
Thank you. Example number one. Example number one. Example number one. A digital signal processing system, a DSP system. A DSP system is described by is described by the difference equation by a difference equation by a difference equation. Look, the difference equation is given y of n minus 0.5 y of n minus 1 equals to 5 multiplied by 0.2 to power n u of n. Now, determine the solution. Look, please, determine the solution. Determine the solution. The solution. Determine the solution when the initial condition, when the initial conditions, when the initial condition is given by y of minus 1, y of minus 1 equals to 1. Now, to solve such a system, first of all, we have to determine the rank of the system. As you can see in this equation, it's a recursive equation, of course. First of all, it will be a recursive equation. First of all, we have y of n and y of n minus 1. Just we have y of n minus 1. We don't have, for example, y of n minus 2, y of n minus 3, and so on. So this system is called first order system. Okay, this kind of system will be what? Will be first order system. First order system. Why? We are talking about what? About y of n, sorry, about only y of n minus 1. Okay, y of n minus 1. Now, if we have, for example, y of n minus 2, at that time it will be second order system. Second order system will be y of n minus 2. Of course, third order, fourth order depend upon the y of n minus 2, y of n minus 3, minus 4, and so on. Well, now we have talked about the order and the rank of the system. The most important thing, the initial condition y of minus 1 is equal to 1. So to solve such a problem, what we are going to do, we are going to follow the 4 steps that we have explained in the first lecture, first hour, I mean. So first of all, let us take the Z transformation for the both sides of the equation. Now, the Z transformation for y of n will be what? Will be y of z minus 0.5. In this time, we have the Z transformation for y of n minus 1, but what? With initial conditions. So we have to apply the derived equation. Look, in the previous lecture, we have derived a formula for what? For y of n minus 1. Look, this is for what? For y of n minus 1. Y of minus 1 plus z to minus 1 y of z. Okay, so instead of y of n minus 1, y of n minus 1, the z transformation for y of n minus 1, look, minus 0.5 multiplied by what? Y of minus 1 plus z2 minus 1 y of z equals to the z transformation for the right hand side. Look, right hand side, we have 0.2 to power nu of n multiplied by 5. So it will be 5z over z minus 0.2. That's it, no more, no less. Okay, now we have what? We have determined the z transformation for the both sides of the equation. Now, what will be the next step? Look, in the first step, we have what? We have determined the z transformation for the right and left sides of the equation. So the z transformation for y of n will be y of z minus 0.5. Z transformation for y of n minus 1, we have to take into our account the initial conditions. So it will be y of minus 1 plus z to minus 1 y of z, and equals to 5z. Of course, the right side will be 5 by 0.2 to power n of n. It will be 5z over z minus 0.2. This is the what? This is the first step. We said that in the second step, what we are going to do, we are going to substitute the initial conditions into the equation. So the initial condition, as you can see, it is 1. Y of minus 1 equal to 1. So the equation becomes y of z minus 0.5 multiplied by 1 plus z to minus 1, z to minus 1, y of z equals to 5z over z minus 0.2. Okay, these are very important two steps. Okay, why? Even when you are going in the exam, the first two importance are what? The first and second steps. Why? Any mistakes in the first or the second stage, or these two lines, okay, will lead to what? Will lead to find out wrong output. Okay, so you have to be care when you are going what? You are going to determine the z transformation for the both sides of the equation, and then when you are going to substitute the initial condition. After that, we have to simplify the equation, okay, and solve for what? For z. Now, what I am going to do, I am going to expand this brackets, okay? So it will be y of z minus 0.5 minus 0.5 z to minus 1 y of z equals to 5z over z minus 0.2. Well, now what will be the next step really? Now you are going to take this 0.5 to the what? To the right side and simplify the equation. Well, now this will be y of z minus 0.5 z to minus 1 y of z equals to 5z over z minus 0.2 plus 0.5 plus 0.5. Well, now look at the left hand side, take y of z as a common factor. Now y of z taken out, the remaining will be 1 minus 0.5 z2 minus 1, and this will be the other equation again can be simplified by finding the common denominator and solve. It will be 5.5 z minus 0.1 divided by z minus 0.2. This will be the equation after simplification. Now, what will be our target? We said that in the second step, you are going to substitute the initial condition. Now we have substituted the initial condition. In the third stage, we said that what? You have to solve for y of z. What do you mean by solve for y of z? I mean put the y of z at the left-hand side and the rest of the equation to the right-hand side. So it will be y of z equals to 5.5 z minus 0.1 divided by 1 minus 0.5 z to minus 1 multiplied by z minus 0.2. Z minus 0.2. Okay. Now, what will be the next step? Really look at the equation here. The equation contains positive and negative exponents. Look at me, I mean 5.5 z minus 0.1. And in the denominator, we have 1 minus 0.5 z to minus 1, z minus 0.2. We don't have the ability to work with such a numerator and denominator. So what we are going to do, of course, I'm going to unify the exponents. I mean, I'm going to work with positive exponents. So how? Numerator and denominator will be multiplied by z. Okay, so multiply numerator and denominator only by z. Okay, so y of z will be z multiplied by 5.5 z minus 0.1. Now, the z in the denominator will be what? Will be used to enter the first bracket. Okay, it will become z minus 0.5. That's it. And z minus 0.2. Okay, we have multiplied by single z over z. Now, uh, the second objective, now we have explained or expressed the system in terms of what? In terms of y of z, okay? In terms of what? In terms of y of z. So this is the y of z, okay? This is the y of z. What will be the remaining really? The remaining is to determine the inverse z transform, okay? The remaining will be what? Will be to determine the inverse z transform. Of course, I mean our target is to determine y of n, okay? I need to determine y of n, of course, how? By using the inverse z transformation. So, what we can conclude when we are talking about the difference equations, the student must master the whole processes of the Z transformation. I mean what? I mean finding the Z transformation of the functions and finding the inverse Z transformation and finding the Z transformation for non-zero initial condition systems. So by solving the difference equation, the student will master the topic of the Z transformation, and you need the all Z transform tools to be able to determine the solution of the difference equation. Now, as I have talked about the inverse Z transformation in the previous lectures, in the previous week, we have to arrange the equation as y of z over z. Okay, so I'm going to take, sorry, I'm going to take this one, this z here. Okay, so the equation becomes y of z over z. Okay, equals 5.5 z minus 0.1 divided by z minus 0.5 multiplied by z minus 0.2. Okay, now this will be the new equation. Now look at the remaining. I mean 5.5 z minus 0.1 divided by z minus 0.5 multiplied by z minus 0.2. This is, look at the numerator. I mean, numerator order is 1, while the denominator order we have 2 poles. Okay, it means in the second order. Now you can apply the partial fraction y. Numerator order or rank is less than the denominator order. So easily you can what? You can determine the inverse or partial fraction for the system. So y of z over z will be a, okay, over z minus 0.5 plus b over z minus 0.2. Of course, what we are going to do, of course, we are going to determine the values of A and B, and then we will be able to determine the inverse. Now A will be Z minus 0.5 multiplied by Y of Z over Z, which is this value, okay, and substitute at Z equals to 0.5, okay, and Z equal to 0.5, it will be really 5.5 Z minus 0.1 divided by Z minus 0.2 at Z equals to 0.5. Substituting and simplifying the equation, A will be 8.833. Okay, this is for what? For A. For B, it will be Z minus 0.2 multiplied by Y of Z over Z, and substitute when Z equals to 0.2, and it will be 5.5 Z minus 0.1 divided by Z minus 0.5, and substitute when Z equals to 0.2. الله دقة to arrange it. To take the space, Z equal to 0.2. Yes, it equals to, becomes at Z equal to 0.2. It will be 5.5 Z minus 0.1 over Z minus 0.5. Substituting by Z equal to 0.2, the result will be minus 3.333. Okay, now after that, we have determined A and B. Now Y of Z over Z will be 8.833 over Z minus 0.5 minus 3.33 over Z minus 0.2. Now we can easily reback this Z. Okay, now we can easily reback this Z, just as multiplying both sides. Okay, multiply both sides of the equation by what? By Z. So Y of Z becomes 8.833 Z over Z minus 0.5 minus 3.33 Z over Z minus 0.2. Now easily we can determine the inverse. I mean, inverse to the left side will be Y of N. Okay, inverse of the left side will be Y of N, and this one will be 8.833.5 to power N U of N minus 3.33 multiplied by 0.2 to power N U of N. Okay, this will be the full solution for the previous example. Now, do you have any question about the steps for the solution of this example or not?
دكتور
بلا عيني. ايه تفضل.
بس فوق، بس شوية اطلع لي فوق. انت ضربت في زد على زد، ليش؟
تعال خلينا نطلع على الزد في زد. وينها هذه؟ هيانها ضحك. خوش سؤال. اوكي، الان عندنا y of z 5.5 z minus 0.1. هتشوفها مو تمام؟
تمام دكتور.
ايه، 1 ناقصا 0.5 z to minus 1 على z minus 0.2. عندنا ايه هذا الترم بالحقيقه؟ بس دقيقه واحده. ايه انا خليه اجي احسن. ايه هذه هتشوفها، هاي زد ماينس 1 ما تمام؟ هاي زد ماينس 1 عندنا تشوف المعادله كلها دلاله زد يعني بوزيتيف اكسبوننتس. اوكي
تمام
اجبر لي اف قيمتها بس ابى زد تو ماينس 1. اوكي بس هذه زد تو ماينس 1. فعلى ايش لازم اسوي؟ لازم اتخلص من الماينس. اوكي فشلون راح اتخلص من الماينس؟ اذا ضربت البسط والمقام ضربتهم بزد اوفر زد، ايش راح يصير عندنا؟ كانه ضربت في واحد بس راح ادخلها
تمام
على اقواس. فشوف اول حاله طلعت عندي زد خارج القوس خليتها، بس بالمقام دخلت على القوس الاول فقط لانه عندي زد وحده. لو كان عندي زد سكوير كنت ادخل على القوسين، بس عندي زد وحده فدخلت على القوس الاول. فاصبحت شنو ايش صار عندي؟ زد في واحد يبقى عندي زد ناقصا 0.5 زد تو ماينس 1 في زد تو ماينس 1 في الزد يصير عندك شنو؟ زد الصفر يعني واحد، فيصير عندك زد ماينس 0.5. وبهذه الطريقه لاحظ المعادله الثانيه مال واي اوف زد ايش صارت عندي؟ كلها صارت بوزيتيف
دلالة الزد.
بالضبط.
تمام دكتور شكرا.
عزيزي any question؟ في سؤال كديته هي نينا؟ Okay, if you don't have any question, now let us go to the second example, really. In the second example, we have a second order system. Okay, so we are talking about more complicated system. Now, let's go to the second example, example number 2. In example number 2, we are going to talk about a second system. Example number 2. Okay, in example number 2, really we are going to use a new definition. Look please. A relaxed DSP system. Of course, what do you mean by relax?
في حالة توقف.
relaxed مروفك ريلاكس يعني شو تشتهي؟ مرتاحة. نعم
يعني هذا
اذا واحد مرتاح شو تقول له؟ تقول له ريلاكس، يو ار ريلاكس او بي ريلاكس يعني ريح مو تمام. فبس بالدي اس بي سيستم نقول ريلاكس يعني ايش معناته؟ معناته زيرو انيشال كونديشن. اوكي زيرو انيشال كونديشن. فديروا بالكم من هاي الكلمه. whenever you hear relaxed it means what? It means you have a zero initial conditions. Okay, I mean the initial conditions are what? Are zero. So a relaxed DSP, a DSP system is described. Okay, is described by a difference equation. A difference equation. This will be the difference equation now. Look, please. Y of n plus 0.1, y of n minus 1 minus 0.2, y of n minus 2 equals to x of n plus x of n minus 1. Well, now this will be this system. Now
سيدة بس في السيارة كي
بالي كلام كبرى
إنه كان الفيري الشرطة وقت يومها second order بت 1 n minus 1 حاضر بت
نشرته احتمال مثلا بس هي y of n minus 2 نا مشكلة يا
يعني حاجة ما هو شيء y of n minus 3 جي هي ده third order وده يعني كنا
دي تشابت
درسته.
وطبعا النقطة كادي درستها في سؤال قال لك لا براستي نقطة كادي اوردر سيستم عند تحديد كين نسبته واي. يعني مثلا صح رخي راست مثلا انتهي n و n minus 1 و n minus 2 و n minus 3 ما مشكلة نينا چونك هذا انبوتا بس عند تحديد كين اوردر سيستمي ديف واي اوتبوت. اوكي يعني انه كاف سيستم مثلا بري خوب ده رخي راست كم ده n minus 1 نا n minus 1 هذا اكسا بس رخي تشاب n minus 2. So we have what? We have second order. Always we are going to determine the rank of the system or order of the system based on the what? Based on the output. Well, it's a good question. Well, now what will be the requirements for this problem? Now the requirement for this problem will be the following. A, determine output y of n due to impulse response, due to impulse sequence, okay? Due to impulse sequence x of n equals to what? Equals to delta of n. And second, B, in the second branch, again, we are going to determine y of n due to x of n equals to u of n. Well, so in this system, we have two kinds of input. First one will be what? Will be the delta function, and for the second time we have the unit step function. Really, this question is a second order, but at the beginning of this problem, the question tells us about the relaxed DSP system. It means what? It means that all initial conditions are 0. So in this time, when we are going to talk about Z transformation for y of n minus 1, it will be Z to minus 1 y of Z only. Why? Y of minus 1 already is 0. So we are not going to talk about the initial conditions, which is already 0. And the Z transformation for y of n minus 2 will be Z to minus 2 y of Z. Okay? So when we talk about a relaxed DSP system, it will be easier than non-relaxed DSP system. So what we are going to do to solve such a problem, again, we are going to take the Z transformation for the both sides of the equation and solve for y of Z. So it will be y of Z plus 0.1 Z to minus 1 y of Z minus 0.2 Z to minus 2 y of Z equals to x capital of Z plus Z to minus 1 x of Z. Is good. Now we have determined the Z transformation for the both sides of the equation. Now let us simplify the equation. I mean, I'm going to take y of Z as a common factor here. So the remaining will be 1 plus 0.1 Z to minus 1 minus 0.2 Z to minus 2 equals to what? Equals to take x of Z as a common. Now the remaining will be what? Will be 1 plus, the remaining will be 1 plus Z2 minus 1. Now, up to this point, I'm going to use this equation for two kinds of input x of Z. I mean, first one will be delta of n. In the second time, we are talking about what? About the unit step function. So I am going to use both functions. Okay. So first one, delta of n. And as you know, the Z transformation for the delta of n, Z transformation for delta of n will be 1. Okay, it is known that the Z transformation for delta of n is equal to 1. So easily we can determine the Z transformation for this one. Now y of Z multiplied by 1 plus 0.1 Z to minus 1 minus 0.2. Z2 minus 2 equals to, instead of x of z will be 1. Okay, so the remaining will be 1 plus Z2 minus 1. Now, next step is what? To simplify the equation and determine y of z. Y of z will be as follows. 1 plus Z2 minus 1 divided by 1 plus 0.1 Z2 minus 1 plus, minus 0.2 Z2 minus 2. Of course, in this equation, you can note something. We can note something. It is what? Look, please. In this equation, we have Z2 minus 2. Okay, we have Z2 minus 2. So I'm going to multiply numerator and denominator by Z square to get rid of from the what? From the positive exponents. So the equation becomes y capital. We have to have y capital. Now y capital of z will be z squared plus z divided by z square plus 0.1 z minus 0.2, and it will be simplified more and becomes z multiplied by z plus 1 divided by z minus 0.4 multiplied by z plus 0.5. Of course, look, please, again, I have another important note here. When you are going to expand or fraction this z square plus 0.1 z minus 0.2 into two roots, or finding the roots of the denominator, we have a way by which it's called trial and error or anything else. Directly you can use the quadratic form in our native language and the store. Well, so it will be z1 2 minus b plus minus, if you remember this equation, b square minus 4ac minus 4ac divided by 2a. Okay, to find the roots of the second order system, you may use this equation, minus b plus minus b squared minus 4ac over 2a. Directly you can determine the answer without mistakes. So after that, the equation can be expressed as y of z over z becomes what? Becomes z plus 1 divided by z minus 0.4 multiplied by z plus 0.5. Of course, again, here y of z will be partitioned into two parts. Okay, now it will be y of z over z equals to a over z minus 0.4, z minus 0.4 plus b over z plus 0.5. Again, we may solve for a and b. Okay, يعني a will be z minus 0.4 multiplied by y of z over z when z equals to 0.4. Directly you can calculate it really, and I'm going to give you the final answer, which is 1.5556. And for b, the same thing. For b again, b will be z plus 0.5 multiplied by y of z over z Okay, at z equals to minus 0.5, sorry, at z equals to minus 0.5, and the result for B will be minus 0.5556. Now y of z over z, y of z over z will be the following: 1.5556 over z minus 0.4 minus 0.5556 over z plus 0.5. Now we can reback the z to the equation, and here we have y of z equals to 1.556z over z minus 0.4 minus 0.5556 z over z plus 0.5. Yes, z plus 0.5. Now we can determine the inverse z transformation for the both sides of the equation. Left side becomes y of n, and the right side will be 1.5556.4 to power n u of n minus 0.5556 multiplied by minus 0.5 to power n u of n. I'm sorry, I have to move it to the next line. Okay, minus 0.5556. Here we have a plus. Look, please. This is a plus. Okay, this is a plus. So here we have minus 0.5 to power n u of n. And this will be the solution for what? For the first branch. Okay, now, what will happen when we are going to talk about the second case? Okay, what will happen when we are going to talk about the second case? Of course, the same thing will be repeated, but in this time, x of z for the u of n will be what? Will be z over z minus 1. Okay, this is for what? For branch B. For branch B, x of z will be z over z minus 1. Of course, I'm going to utilize the previous equation. So y of z directly will be the following: z over z minus 1 multiplied by 1 plus z to minus 1 divided by okay, yes, multiplied by 1 plus z to minus 1, 1 plus 0.1 z to minus 1 minus 0.2 z to minus 2. Okay, this will be the equation. Now you can simplify the equation more by, of course, multiplying by z square and by z square, and simplify. You can get the following equation: z squared multiplied by z plus 1 divided by z minus 1, z minus 0.4, and z plus 0.5. So in this time, we have what? We have 3 roots or 3 poles in the system. So we are going what? We are going to apply the, this becomes y of z over z, and the remaining will be z multiplied by z plus 1 divided by z minus 1, z minus 0.4, z plus 0.5. Of course, it will be a over z minus 1 plus b over z minus 0.4 plus c over z plus 0.5. Of course, you can do it by yourself, determine a and b and c, and finally y of z will be the following. Okay, y of z over z, I will give you the values, will be 2.22 z, sorry, 2.22 divided by z minus 1 minus 1.037 divided by z minus 0.4 minus 0.1852 over z plus 0.5. Now y of z will be 2.22 z over z minus 1 minus 1.037 z over z minus 0.4 minus 0.1852 z divided by z plus 0.5. Now y of n, I mean the inverse for the left and right side of the equation, will be 2.22 to u of n, okay, z over z. Look, the inverse for z over z minus 1 will be what? Will be u of n, okay, minus, now z over z minus 0.3, it will be 0.4, sorry, it will be 1.037.4 to power n u of n, and finally the z inverse z transformation for z over z plus 0.5, it will be minus 1.185 multiplied by minus 0.5 to power n u of n. This is the complete solution for the second example. So please, you have to go back home and try to solve these examples by your hand, okay? Because it will take more time in the exam. So you have to train yourself by solving more questions, okay? And I am going to give you a tutorial sheet about the Z transformation to be able to solve a set of difference equations. That's it about the lectures of today. We have talked about the solution of difference equation, and we have talked about the initial and final value problems of the Z transformation. Do you have any questions or not? I am waiting for your questions if you have. If you don't have any questions, so this will be the end of this lecture. Okay, thank you for your attendance and see you next week, inshallah.